Hi, welcome back. We're working on classifying triangles today. Our objective is that we're going to classify these triangles by their angles and their sides using marks of congruence. On the skill practice, you'll also see that you'll need to do it with coordinate geometry. Just use the distance formula for that one. You can check out the distance formula videos in previous episodes. So let's get started and let's look at classifying first off by the angle. So here we have classifying triangles by the angle. If the angle, the three angles of your triangle are all acute angles, we're going to call it an acute triangle. Well, in order for it to be considered an acute angle, please recall that acute angles have a measurement somewhere between 0 degrees and 90 degrees. It must be bigger than 0, it must be smaller than 90. Equiangular triangles, the word equiangular means equal. So all of the measures of all of the angles are all equal to each other. We're going to use these little arc figures inside the angles to show congruence. Every angle in your figure that has the same number of arcs are all congruent to each other. For obtuse triangle, you need one and only one angle to be obtuse. Please recall that in order for an angle to be considered obtuse, it must have a measure somewhere between 90 degrees and 180 degrees. Not 90, not 180, somewhere between them. Bigger than 90, bigger than 180. For a right triangle, you need one and only one right angle. Please recall that this symbol right here, the little square box thing in the angle, shows you that that angle is a 90-degree angle. It is a right angle. So please recall that in order to be considered a right angle, your angle must have a measurement of exactly 90 degrees. To classify angles by side, we have three different options for you. We have the equilateral triangle, equa meaning equal, lateral meaning side. So equilateral translates literally to equal sides triangle. We're using these little straight line marks. I know that you've seen them before in previous episodes to show congruence. The isosceles triangle has at least two congruent sides. You could have more, and that's perfectly okay, but as long as you have at least two sides that are congruent, you have an isosceles triangle. Notice here how we have two little lines showing that those sides are congruent. That's telling us that these sides are congruent to each other, but not necessarily congruent to anything else on our page. The scalene triangle is the triangle in which no sides are congruent, so the measures of each side are going to be different from each other. Let's take a moment to practice identifying by sides whether triangles are equilateral, isosceles, or scalene. I have three triangles sitting here. I have the one big triangle, JKL, and I have the two smaller triangles, JKM and KML. I'm also told that M is the midpoint of line segment JL. This point right here is the midpoint. Recall, midpoint means the points in the middle. Because the point is in the middle, it creates two equal congruent segments on either side of it. Looking over at segment JL then, if JM is the midpoint of line segment JL, this line segment on this side of M is congruent to this segment on this side of M. Right now, we're able to tell that triangle JKM, this triangle right in here that I have colored for you, is at the very least an isosceles triangle. And we can say that because we have two congruent sides, side JM and side MK. Now we have to figure out if this final third side, JK, is congruent to the other two. We can do that by their measure. We're looking at side JL, which has a measure of 1.5 units. Because M is the midpoint, JM is half of JL. JM is 1/2 of JL. Going to my calculator, I type in 1/2 times 1.5, and my calculator will give me a final result of 0.75. Because JM is 0.75 and JK is also 0.75, I can say that those two sides are congruent. This means that triangle JKM is most definitely an equilateral triangle because all the sides are congruent. Let's look at the final example. We're going to use algebra in order to calculate and find the measures of the sides of this isosceles triangle ABC. We see some congruent markings right here, which automatically tell us that side AC is congruent to side BC. That gets written this way. Once we know those sides are congruent, we can write that their measures are equal. That gets written this way. Now that I have the measures, of the sides being equal, I can substitute for the information that I already have. The measure of AC is 4x plus 1. The measure of BC is 5x minus 0.5. Sorry that decimal is a little hard to see. I'm going to go ahead and use my algebra techniques to solve this for x. I'm going to move the 4x over to the right-hand side, leaving me with 1x over there. And then I'm going to add 0.5 to both sides to get rid of it on the right-hand side. That leaves me with x being 1.5. I'm not quite done with this example, however, because the question didn't ask for the value of x, it asked for the measure of the sides. And so I must make sure that I finish off by completing some substitution here to figure out what the value of each side is. I'll let you, whoops, I put the wrong letter there. I'll let you go ahead and finish that up on your own. Please feel free to see me in class or after school for tutoring, and I'll be happy to look that over for you. Make sure you're doing it right. Thanks for watching.